Now let's take a look at the third part. So here we assume that the consecutive injection is additive. The concentration is additive. And in the second injection, you are allowed only 75% of the amount originally injected. And then we need to figure out the time for the third injection. What is the time for the third injection? So after the second injection, when the concentration drops down to 0.25 milligram per millimeter, then that would be the time for the third injection, right? So with that, we should write down the relationship here. So this is what we developed. So the concentration should be equal to the concentration. So concentration from first injection, right? Plus the concentration from the second injection. And as time goes by, the concentration will decrease. When do you give the third injection? When this is equal to the 0.25 milligram per millimeter. So that would be the time we give the third injection. And what is the concentration from the first injection? We already know that would be E over 3 divided by x, e to the negative x over 3, right? And what is the concentration from the second injection? We know it also will be E over 3. Now, the second injection is given when at this time, right? We solve that in second part, right? So its concentration should be equal to x minus this time, right? Minus this time, because this is given after this time. For now, I'm gonna just use the more digits you use, the better. I'm gonna use just these for now, but in your program, type in 8 digits if possible, equals 0.25. So if you're able to figure out the figure out the x, that's the time you should give the third injection. Again, this equation is not yet a root finding problem, so you want to convert that to a root finding problem by subtract 0.25 to both sides and make this a new equation. So this will be your new f of x. You're solving f of x equals t. So I'll stop here. That's the hint that I would like to give you. Once you solve this x, that will be the time for the third injection. So this is the hint for the last part.